Hi, my name is Thái Nguyễn. I'm a PhD candidate at Tulane University working with Dr. Tai Ha, and I am on the job market this year. My primary research interest lies on commutative algebra with a lot of combinatorial and computational flavor and their interaction with algebraic geometry, combinatorics, and polyhedron geometry. The following are main projects that I've been working on during my PhD program. The main theme is the study of symbolic powers. For the first project, focus on symbolic powers of monomial ideals, which is the special case of what we call graded families of monomial ideals. The second project, focus on symbolic powers of ideals of points in projective space. So the broad problem that motivated the first project is to study the connection between algebraic properties and invariance of the graded family of ideals and the geometric properties and invariance of some associated convex body. In my joint work with Dr. Tai Ha, we focus on graded family of monomial ideals, and we use combinatorial data of the so-called Newton-Okunkoff body to characterize the Noetherian properties of the Riesz algebra of the graded family. In terms of algebraic invariant, we give a combinatorial interpretation for the analytic spread of the graded family. We focus on symbolic powers. We give bounds for symbolic generation type and the standard Veronese degree. In the future, I want to investigate further the connection to other invariants and properties to the graded family. I also want to extend the existing result for graded families of larger classes of monomial ideals, or possibly for graded families of ideals in general. In the second project, there are two motivating problems. The first one is the polynomial interpolation problem regarding the question about homogeneous polynomial that vanishes along given set of points with some given multiplicities. The second motivating problem is the ideal containment problem. In my joint work with Sankanel Bisui, Eloise Zagrev, and Tai Ha, we study lower bounds for the initial degrees of symbolic powers of ideal of points in projective space. In particular, we verify Chetnowsky's and Demey's conjectures for any finite set of sufficiently many general points by utilizing specialization and proving the stable Harborn-Hünicke containment. In this project, I also calculate the exact value of initial degrees of symbolic powers of ideal come from special configuration of points. In the future, I want to extend the existing result to any finite set of general points, and also study the conjectures for ideals beyond points. I also want to study the ideal of singular loci of some hyperplane arrangement, because it seems this provided a good resources for counterexample for the above conjectures. Lastly, I want to mention some of the kind of broad problems that I am very much interested in working on in the future. The first one is I want to investigate further the connection between algebraic problems and polyhedron geometric problems. The second one is I want to investigate the connection between questions about Hilbert functions and questions in algebraic statistics. Lastly, since I have some experience on monomial ideals and graphs, I want to explore and work more on problems involving interaction between monomial ideals, graphs or simplistic complexes, and integer programming. Thank you for listening.